In this video, we'll run through some of the basic operations with integers. First, let's take a look at some addition examples. If we want to add -5 plus 3, we can think about this operation using the number line. If I start at the number -5, 5 places to the left of 0, and I want to add 3, that just means go 1, 2, 3 places to the right. That takes me to -2. So -5 plus 3 is -2. Now, we don't want to have to draw out a number line every time we add numbers together. So there is a faster way to think about this pattern. If we add two numbers with opposite signs, so a negative plus a positive, or a positive plus a negative, we're actually going to subtract their magnitudes, and then the answer will take the sign of the number with the larger magnitude. So in the example we just did, 5 minus 3 is 2. 5 is bigger than 3. Since the 5 was negative, the answer is negative. Or if we take 5 plus -9, the difference between 5 and 9 is 4. If the 9 is negative and 9 is bigger than 5, the answer will be -4. Notice if I switch the signs, -5 plus 9, I can do the problem the same way. 9 minus 5 is 4, but now the positive number, the 9, is bigger than the magnitude of the negative number, 5. So the answer will be positive. If we want to add two numbers that have the same sign, we can add their magnitudes and the answer will keep that sign. So for example, -3 plus -11, both numbers are negative, so 3 plus 11 is 14, and the answer will be -14. If we want to add more than two numbers, we can actually do addition in any order we want. I can go from left to right, -2 plus 17, opposite signs, so I subtract them. 17 minus 2 is 15. Positive 15 because 17 is bigger than 2. And then I could take positive 15 plus -6, opposite signs, so I subtract the numbers, and I get +9. So in this case, I added from left to right, but I could actually go in any order I want. I could start by taking the -2 with the -6. Same sign, we add the numbers. -2 plus -6 is -8. And then -8 plus 17, opposite sign, so I subtract, and I get +9. Subtraction is really similar to addition, and in fact, subtraction can be thought of as adding the opposite. Every single subtraction problem can actually be rewritten as an addition problem. So for example, 12 minus 8, we might know that that's just 4. If you take 8 away from 12, you get 4. But you can actually think of this problem as 12 plus -8. That is 12 plus the opposite of +8, and that is also 4. 12 plus -8, opposite signs, so we subtract them. Or if we have -4 minus 6, that's the same thing as -4 plus -6. Same sign, we add, and we get -10. Now, if we are subtracting a negative number, that pattern of adding the opposite still holds. If we are subtracting a negative number, that actually turns into adding a positive. When you see minus a minus, you can turn that into a positive. So -7 minus -3 becomes -7 plus 3. Different signs, so we subtract and get -4. 15 minus -9, same reasoning, turns into 15 plus 9. Minus a negative turns into a plus. And 15 plus 9 is 24. Okay, so here's our rule. Subtracting a positive number is the same as adding a negative. Subtracting a negative is the same as adding a positive. Subtracting is adding the opposite. To multiply integers, we can multiply like we normally would, but anytime the signs are different, if we have a negative and a positive, the result will be negative. If we have two negatives, negative times negative, the result will be a positive. So -3 times +8 is -24. -5 times -9 would be +45. If we want to multiply more than two numbers, we can multiply in any order we want. So for example, if I want to go from left to right, I can start by taking -4 times -7, and that's going to give me +28. Then I can take that result of 28 and multiply that by 9. Let's see, this is one that I can't do in my head. So 28 times 9, 8 times 9 is 72. And then 9 times 2 is 18. 18 plus 7 gives me 25. So 252 would be my final answer. One other thing I'd like to point out in these problems is notice that if you see two numbers, or in this case even three numbers, and they're next to each other and there isn't a sign, it means multiplication. Sometimes we use little dots to represent multiplication, but sometimes if we just put numbers or parentheses next to each other, that also means multiplication. Now I multiplied by going from left to right, but I can work in any order. I could have taken the -7 times 9, that's -63, and then that result, -63 times -4, should give me the exact same answer of 252. And let's see, we can check. 4 times 3 is 12, carry the 1. 4 times 6 is 24, plus 1, 25. Now when we're dividing, we actually have a very similar rule. If we are dividing numbers with opposite signs, so positive divided by a negative, or negative divided by a positive, we'll get a negative answer. If we divide a negative times a negative, or a positive by a positive, we get a positive answer. These are the same rules we had with multiplication. So -60 divided by 5, one negative divided by a positive, gives me -12. Now, if you don't know that 60 divided by 5 is 12, you can write that out. We can do some long division here. You would go 60 divided by 5, and let's see, 5 goes into 6 one time. 1 times 5 is 5. So 6 minus 5 is 1. And then we bring down the 0. 5 goes into 10 two times. 2 times 5 is 10. There's no remainder. So that is our quotient. -60 divided by 5 is -12. All right, -12 divided by -2. We've got two negatives, so we'll get a positive. And that's going to be +6. Here's a couple more examples. Negative 237 divided by negative 4. The answer will be positive. Let's see, that's not one I can do in my head, so I'll write it out. 4 goes into 23 5 times. 5 times 4 is 20. Subtract to get 3, and then I bring down the 7. 4 goes into 37 9 times. 9 times 4 is 36. Subtract, and I get 1. There's no more numbers to bring down, so we can actually stop our division here. The 1 is our remainder, and we can rewrite our answer as 59. 59 is our quotient. 59 and 1 over 4. 59 and 1/4. Notice you can write that as your remainder. Remainder is 1 over your divisor, which was 4. So this is 59 and 1/4. Now what if we want to do division problems that involve 0? 0 divided by 8 is going to be 0. Right? If I have 0 cookies that I want to divide among 8 people, well, everyone gets 0 cookies. 0 divided by any non-zero number is 0. But if I switch the order, what if I have 8 cookies and I'm going to divide those among 0 people? Well, that's not something we can do. That is actually undefined. And division by 0 is always undefined. We can never divide things up into 0 groups. So if 0 is on the bottom or divide by 0, that is always undefined. All right, one more operation. What about exponents? So 3 to the third. Exponents just mean repeated multiplication. 3 to the third means we take 3 times 3 times 3. We multiply 3 by itself 3 times. And 3 times 3 is 9, times another 3 is 27. Exponents have the same meaning even if the base is negative. So negative 3 to the third is negative 3 times negative 3 times negative 3. Minus 3 times minus 3 is positive 9, times another negative 3 is negative 27. We'll be talking a bit more about exponents later on, but for now, we'll just have to remember that exponents means repeated multiplication. So whatever the exponent is, we write out our number that many times and multiply. Finally, let's see what happens when we combine all of these operations together. To solve problems that involve multiple operations, we can use what's known as order of operations. Many people like to use the acronym PEMDAS to help them remember their order of operations. I believe you can remember the phrase, "Please excuse my dear Aunt Sally," as kind of a memory device for PEMDAS. But what this means is when we're doing order of operations, the first thing we have to do is work inside parentheses or other grouping symbols. A grouping symbol might also be brackets or absolute value bars. After parentheses, we do the exponents, and we'll also do any square roots in this stage as well. Then the MD means we multiply and divide from left to right. So we'll actually do those steps at the same time. Multiply and divide, working from left to right. And then finally, we'll finish by adding and subtracting, again, working from left to right. So let's take a look at a couple of examples. 3 minus 2 times 14. There's no parentheses, there's no exponents, so then I have to multiply or divide first. So I'm going to start by taking 2 times 14. That gives me 28. Now 3 minus 28 is the same as 3 plus negative 28. Opposite sign, so we subtract. 28 minus 3 is 25, and the answer is going to be negative. Here's another one. I've got, let's see, parentheses, 6 minus 4 squared minus 3. And then these straight bars here are actually absolute value bars. And absolute value takes a number and makes it positive. So using our order of operations, we're going to start by working inside the parentheses. So 6 minus 4 is 2. Now notice when I'm doing complicated order of operation problems, anytime I do a step, I actually write down the whole expression again, just because I don't want to lose track of anything. So parentheses, 6 minus 4 is 2, minus 3, and these absolute value bars act like a grouping symbol. These are kind of like parentheses. So 4 minus 6 is negative 2. So I've got 2 squared minus 3, absolute value, negative 2. Now I'm going to do my exponent, 2 squared, so 2 times 2 is 4, minus 3, absolute value, negative 2. Absolute value, again, these straight bars that you see, takes the number inside of them and makes it positive. So absolute value of negative 2 turns into positive 2. And we're left with 4 minus 3 times 2. We have to multiply before we can add or subtract. So 3 times 2 is 6. And finally, 4 minus 6, that's 4 plus negative 6, is negative 2. Here's another one. 5 plus 2, and this symbol right here is a square root. So 5 plus 2 square root 9. There's no parentheses, so then I would move to the exponents. And we actually do square roots at the same time that we would do exponents. You can think of a square root as similar to an exponent. So square root of 9 basically means what squared would give you 9. And so you really just have to think about your times table. 9 is the same as 3 squared, so square root of 9 is 3. So now we've got 5 plus 2 times 3. I multiply before I add, so 2 times 3 is 6, and 5 plus 6 is 11. All right, here's my last example. Negative 11 plus 2 times 4, all divided by 6, divided by 3 minus 1. So in this problem, this big fraction bar acts as a grouping symbol. So we have to simplify everything on the top and everything on the bottom first, and then that fraction bar means divide. So a fraction bar is kind of like a grouping symbol as well. It's separating the top from the bottom. So I'm going to start by simplifying the top and the bottom. So negative 11 plus 2 times 4. I have to multiply first. 2 times 4 is 8. So negative 11 plus 8. On the bottom, I'm going to have to divide before I can subtract. So 6 divided by 3 is 2. So now I've got 2 minus 1 on the bottom. Minus 11 plus 8 is minus 3. And 2 minus 1 is 1. And then finally, negative 3 divided by 1 is negative 3. All right, and that was my last example in this video. Please reach out if you have any questions on any of these examples.